Hello everyone, this is the demonstration and tutorial video of refractometer. Refractometers are the instrument that is used to measure the substances that are dissolved in water or certain oils. The refractometer works using the principle of light refraction through the liquid. As the light passes from air into a liquid, it slows down and it changes the direction. Refractometry is the analytical method of measuring substances' refractive index, which is also one of the fundamental physical property, and this is done to assess their composition, purity, or concentration. So, typically, a refractometer is measuring the refractive index of the substance. A refractometer measures the content in terms of bricks or sugar, urine, salt, battery fluid of a solution through the reflection of the light. Using an optical refractometer, we can just put simply few drops of the sample liquid on the angled prism, and then we seal it with a plate so that there is no interference from outside, and take the reading for that. We will look for the same in the later part of this video. The prism, so as I said, the refractometer is also used to measure the concentration of a solution. So if you look over here, this is how the ray diagram through the prism of refractometer looks like. The prism in the refractometer has a greater refractive index than the solution. So measurements are read at this point where the sample touches the prism. With a low concentration solution, the refractive index of the prism is much greater than than that of the sample, creating a large reflection angle and a low reading. Similarly, the reverse happened with a high concentration solution if you look clearly in this ray diagram. So how does the refractometer works, and what are the basic techniques that we need to take care while using a refractometer will be discussed in the later part of this video. Thank you. Hello everyone. As we have already seen the tutorial part of refractometer, now let's look at this instrument which is used to calculate the refractive index or the Briggs percentage. This is a simple refractometer, a benchtop, a small one, which is very compact in its structure, and it is commonly utilized for calculating the refractive index. So, as I already told you, the principle and the working principle involved behind refractometer. Now, let's look at how basically you use this instrument for your applications. So, the instrument has a power supply through a battery. So, we'll just connect it. Uh, we'll just connect these port, and we'll just keep it here. Once this is done, we can now switch on the instrument. So the instrument initially shows the temperature value, which is displayed on the system. Now, if you look at the instrument has 4 buttons basically. The one is direct on or off button. It has read. It has a 0 button, which is for the calibration, and it is for the ranging. So now let's try to calibrate the system with distilled water for our experiment. You can use the calibration as per the requirement of your experiment. So we'll just put the water and we'll calibrate it. Before that, the value which are given here is in percentage Brix, which is basically the concentration of sucrose in 100-gram solution. So I will now calibrate this system. I'll use a dropper to properly take the distilled water, and I'll put the distilled water in the surface provided for the sample. Make sure that you provide enough sample to cover the well like or the groove which is being displayed here. And Let's now we'll cover before taking the reading, we'll just cover so that there is no interference from outside, and we'll just set it to 0. So if you can see, it gives the refractive index value, and it is calibrated, so the value being displayed here is 0. Now let's just wipe the distilled water. You can just use the same dropper to take the liquid out, and just wipe so that there is no residue from the water. Sample that we are going to try is a system of vegetable oil. So while placing the oil or any sample, make sure that you do not produce or you do not make any air bubble, because that air bubble might interfere the light refraction. So I have kept the oil here, and I'll just cover it to avoid any interference from from outside, and I'll just click on the already calibrated system. So the value of percentage breaks over here is 1.47. Now let's look at the other sample, which is also made using the same oil, but it is a fat system, or commonly called as oleogels, and we'll just see how how its value changes, or if the value remains same. So I'll just wipe the surface. I'll just wipe the surface very thoroughly. Make sure that you do not do any harsh scratching on the surface of the or the place where the sample is being placed. I'll now place a minute amount of oleogel. And I'll just spread it evenly so that it covers the entire surface. And I will ask it to read it again. So the values is 1.473. The possible reason is, since this system is made up of majority of the oil which we actually read before, and that's why there's a chance that the value didn't differ much. So this is about the bench refractometer, which is a simple and a very compact structure which can be easily moved to different places for the study, and is commonly used for a wide amount of sample for the calculation of refractive index, or as I told in the tutorial about the concentration of the solution using the same value. Thank you so much.